All right, let's dive in. Today, we're going to unlock one of algebra's most common traps. You know the one where the variable you're solving for is totally stuck inside a fraction. It can feel like you've hit a wall, but trust me, there's a simple key to set it free. Let's get into it.
It's such a frustrating feeling, right? You can see the axe sitting right there, but it feels like it's behind a locked door. You know the whole goal is to get it by itself, but your usual moves they just aren't working here. Okay, take a look at this classic example. The x is part of that x plus 4 group, and that entire chunk is being divided by 2. You can't just subtract the 4 to get x alone, because it's completely locked in there by that fraction bar. So how do we solve this thing? Let's try to think about it a little differently. Imagine the numerator, the x plus 4, is like a VIP section at a club. And that denominator, the 2, he's the bouncer. And there's one very simple rule. You can't get to the VIPs until you get past the bouncer. So what's the actual math behind this whole metaphor? Well, that fraction bar is way more than just a division sign. It's a really powerful grouping symbol. It acts just like a set of parentheses. It basically locks everything on top together, forcing us to treat that x and 4 as a single unit, at least for now. And this slide right here shows you exactly why that grouping is so critical. On the left, x plus 2 is together in that VIP section. So your first step has to be dealing with the bouncer, the 5, by multiplying. But look at the right. Only the x is in the fraction. The plus 2 is outside the rope. So our first step there is to subtract it. Same numbers, totally different order of operations. And that brings us to the golden rule. To unlock that numerator and finally get to the variable, you always, and I mean always, have to multiply both sides of the equation by the denominator first. That's it. That's the master key for every single one of these problems. Okay, let's put this key to the test with our original problem. We've got x plus 4 trapped in the VIP section, and that 2 is playing bouncer. Let's solve this thing. First step, we deal with the bouncer. We multiply both sides by 2. On the left, the 2's just cancel out, finally unlocking x plus 4. On the right, 10 times 2 gets us 20. And just like that, look what we have. A super simple one-step equation. Subtract 4 from both sides, and we find our answer, x equals 16. See? Not so bad. Ready to level up a little? What if the bouncer is negative? So here, y minus 3 is being divided by negative 4. Yeah, it might look a little more intimidating, but the golden rule still works perfectly. Our key, as always, is to multiply by the denominator. In this case, that's negative 4. We do it to both sides, of course. This frees up y minus 3 on the left. On the right, 5 times negative 4 gives us negative 20. Now all we got to do is add 3 to both sides, and we've got our solution. Y equals negative 17. The process is exactly the same. Let's try one more. This one has a common little trick baked into it. Notice how the variable k is being subtracted from 10. Don't let that throw you off. What's our first step? You know it. That's right, we deal with the bouncer. We multiply both sides by 3, which gives us 6 equals 10 minus k. Next up, we isolate that k term by subtracting 10 from both sides, leaving us with negative 4 equals negative k. Now for the final move. We can't solve for negative k, so we just divide both sides by negative 1, which is the same as just flipping the signs on both sides, and we get our nice, clean answer, 4 equals k. Now, knowing the rule is one thing, but it's just as important to know the common traps. The biggest mistake, by far, is trying to talk to the VIPs before you've dealt with the bouncer. Trying to add or subtract inside the numerator first. The second big mistake is forgetting to keep the equation balanced. Whatever you do to one side, you absolutely have to do to the other. I love this quote. It really brings it all together. The variable is trapped inside the fraction house. You must clear the denominator first. So whether you think of it as a bouncer, a locked door, or the entrance to a house, the main idea is exactly the same. Deal with the division first, and everything else gets a whole lot simpler. So you might be sitting there thinking, okay, that's cool, but when am I ever going to use this in real life? Well, how about every single time you want to figure out your grade average? Here is a perfect real-world example. Let's say you want to get a 92 average in a class that has 3 tests. You've already scored an 85 and a 90 on the first 2. So what do you need to get on that final test? Well, when you set up the equation for an average, you get a classic trapped variable problem. First, you get past the bouncer.
Multiply your target average, 92, by the number of tests, 3, which gives you 276. Now that the top is unlocked, you can just subtract your other scores. The answer? You need a 101. Uh-oh, better start hunting for some extra credit. So the principle is really that simple. Always deal with the bouncer before you try to get into the VIP section. You officially have the key to unlock this entire class of equations. You're ready to solve a whole new world of problems. So the only question is, what are you going to unlock next?